In this video, I'm going to show you guys how to use completing the square to go from the standard form of a quadratic equation to the vertex form, which reveals all sorts of characteristics of a function. All right, so the first thing you're going to notice is that when I write out my quadratic function, I'm going to be writing it backwards, and there is a reason for that, because our first step is actually to manipulate this y. So when we are changing from vertex form, the way we want to think about this is we're actually looking at our roots, and roots is another fancy way of saying x-intercepts. And when a graph is intersecting our x-intercept, it just means that the value of y is 0. So that's actually going to be our first step, is to change the value of y to be equal to 0. My second step is going to be to move this c value to the other side. Okay, and so I'm just doing the opposite operation, and what that leaves me with is something that looks like this. Now, I am on purpose leaving this empty space because part of completing the square is actually finding the perfect c value given this b value. If you remember, the way to find your c value is to do c equals b over 2 squared. My b value in this case is 8, so c equals 8 over 2 squared. 8 over 2 is 4, so 4 squared is 16. What I'm going to do with that number is I'm actually going to add it. Okay, it's going to be going in that blank space, but if I'm putting it here, it also needs to go on the other side. So I'll be adding 16 to both sides. So what I'll be left with is x squared plus 8x plus 16 is equal to 29. Okay, so right now, my next step is to actually use my idea of factoring to simplify just this side. Because it is a perfect square, it means that it can be written in the form, and I hope that you guys can see this, it can be written in the form x plus or minus r squared. Okay, so in this case, our r value is actually going to be b divided by 2, because b divided by 2 is 4, and 4 plus 4 is 8, and 4 times 4 is 16. So you can simplify this to be x plus 4 squared equals 29. Okay, our very last step is to move this 29 back over here. And you'll notice I now have the 0 here. And if we go all the way back up to the top, okay, you guys should remember that we changed our y into 0, so we're now just going to change that back. So my final equation is x plus 4 squared minus 29 is equal to y. And I just put that y back up at the front because it is the way that you guys are used to seeing it. So this is now your vertex form. Now, the vertex form actually opens up a lot of doors for you guys because you can do 3 things with it. Number 1, you can find the vertex. Okay, so the vertex is just the opposite of h and then k as it is. So our vertex for this quadratic would be -4 negative 29. Okay, so that would be the vertex of my graph, which in this case is either minimum or maximum depending on which way your parabola opens up. So that's the first thing that you can do with it. That's the simplest part. The second thing you can do are transformations. So that's how your graph is kind of moving around the coordinate plane. And so h, which is the 4, tells you how far it moves left and right from the origin, and the k value tells you how far up and down it moves from the origin. So you would be able to say left 4, down 29. So if you were graphing your parent function, which is x squared, you would take all the points in that function and move them left 4 and down 29. So those would be my transformations. And the very last one is actually the roots. And this one we're going to go backwards a little bit. So if we're talking about the roots, okay, in other words, the x-intercepts of your function, I'm actually going to go back to the equation that looked like this. So before I move that k value back over, I want to use this one because otherwise I have to do some extra steps. So essentially what I'm doing is I'm looking for x, and in order to do that I first have to get rid of this squared value, and the opposite of squaring something is square rooting it. So I end up with x plus 4 is equal to plus or minus the square root of 29 because every square root has a positive and negative value. There are no perfect squares within 29, so you can leave it just like this. And then you're going to subtract 4 on both sides. So the value of your roots would be negative 4 plus or minus the square root of 29. You're obviously welcome to plug that into a calculator and determine the actual decimal value, but this suffices as well.